Hi guys. As some of you know, I'm not known for being gentle with my drones. During my journey into FPV, I've probably damaged or burnt every possible part of a drone in every possible way. In this video, I'd like to share all my tricks and tips that will hopefully let you avoid making the same mistakes I did. When it comes to building durable quads, I believe there's two sides of the coin. The first one is choosing the good parts, not necessarily the expensive parts, but the right parts for the build. The second side is to build clean. When you start hitting walls and concrete and metal, every small thing you get wrong will come back and bite you in the butt. So we're going to build a quad together. I'll show you what components I pick, and I'll show you how I build it to be durable and withstand all the punches. I'm Krhom, welcome to my shop. This build we're going to do now is not going to be the most durable build in the world. It's not going to be the cheapest build in the world. It's not going to be the anything in the world. But what it's going to be is decently cheap, durable, and only cuts where it doesn't matter. So we're going to pick the right parts for that goal. To keep the cost down, I'm going to make use of AliExpress a lot. For those who haven't used AliExpress, I'll put down a link in the description to all the items I purchased. But for each of those items, there are actually many sellers that sell the same item at different price points. And depending on when and how you choose, you can get the exact same item cheaper from another seller. So you're going to have to do a bit of digging on your end to find the best prices. Regarding the build itself, what I want to focus on is all the small tips and tricks that make a durable build durable. But if there are things you want to know more about, so let's say you want to know how to bind the ELRS, or you want to know how to set up Betaflight, leave a comment in the description and I'll answer it. And if many people keep asking the same kind of questions, I'll probably make a video for you and I can go through all the details of that specific step. And of course, in general, if this video is helpful to you, if you like the tips and find them useful, it would be amazing if you were to share the video or give me a like, leave a comment. It's always super helpful. I'm absolutely amazed at how much the channel has grown since last video, and it's thanks to all of you who share and comment and everything. So thank you everyone, and if you can keep doing that, I'll keep making videos. All right. Enough said, let's hop onto AliExpress. I'll pick some components and I'll show you all of that. Let's get building. For the frame, I picked the Chinese clone of the Apex from Impulse LC. It's a frame that flies extremely well, has amazing vibration characteristics, so you can really fly on banged up props. It's quite tough, and for the price, there's absolutely nothing on the market that comes close. However, it is a bootleg copy, so if you have the money, I really encourage you to pick something more creative that fosters innovation. For the stack, I went with the AxisFlying Argus Eco, for the most part because it's cheap, but I have seen it survive many crashes. To be honest, I really believe most stacks are pretty much the same. They all run the same code and fly very similar. This one does have a small advantage that it is very low profile, and we'll see in a bit why it's important. We'll also need a capacitor, because look at that, the one that comes with the stack is just humongous. This one's completely optional, it's the TVS Diode. It is very much up for debate how important they are to run, but they're cheap and I've had good success running them, so I'll use one. The motors were a very easy choice. They're the T-Hobby F60 V4, and they're not really a budget choice so much as they are a good motor for a very reasonable price. I know many people who daily drive those, even where money is no object. As for the VTX, I'm going for the DJI O4 Air unit, lens modded with the O3 lens. I have a video about that lens mod, so make sure you check it out after this one. Oh, but Krhom, you told us the O4 is super fragile. Aren't you trying to build something durable? Yes, I am, and in this video, I'll do my damn best to keep it alive. To be honest though, is there any other choice for a budget HD build? Well, there is, and if you can find a second-hand O3R unit, I would absolutely recommend you use that instead. Otherwise, we'll need the O3 lens for the lens mod, a longer coax cable, since the provided one is ridiculously tiny, and finally, and this one is completely optional, the AxisFlying metal case that will protect your O4 and stop it from overheating so fast. For the receiver, I went with whatever was cheapest at the time. This one's a SpeedyB, but they're pretty much all the same. For the TPU front bumper, we're gonna need a few square nuts. We'll also need some M3x10 socket head screws. Those are optional, but they help keep the arm bumpers on. The frame does come with a strap, but I strongly recommend you get a pair of good quality ones. Another optional accessory is an autonomous buzzer. Here you'll want the Wi-Fi Finder Mini, because it can be turned off without pressing the button, which is important in this frame, and a bunch of TPU prints. Link to the models in the description. I always start by setting up my electronics. I test everything before I start soldering, so it's easier to return if it doesn't work. So here I'm taking note of where I'm gonna plug the O4. It's the one with S-Bus. So it's R1 and T1, UART1. And on the other side, R2 and T2, so UART2, where I'm gonna plug the receiver. I'll power the ESC with alligator clips. Those are from my lab PSU, but you can easily make your own with an XT60 and a couple of alligator clips, and that's super useful to test your electronics. Let's plug it in and jump onto the PC. I'll connect to the flight controller, just going through the motions. There we go. Firmware update, because I always put on the latest version. You never know what silly things manufacturers shove on those boards. I remove all unnecessary options, as they can cause flickering issues with the OSD on some chips. I just made it a habit to remove them. And let's go. Let's go through presets. I have my own preset with my rates and modes. If you want to learn how to do that, leave me a comment in the description and maybe I can make a video about it. Don't forget the Express LRS preset. Pick the one that matches the refresh rate on your radio. Mine is 250, so I picked 250. Next is the HD OSD preset, where we remember that our VTX goes to UART1. Let's quickly check in the ports tab if the RX is correct, and notice that our VTX has been set correctly by the preset. In the motors tab, we make sure bidirectional discharge is selected, and we power it on to ensure it all works correctly. The error goes to 0, we're all good. Since we have a BlueJ ESC, let's go to ESC configurator quickly and check what version's on it. 0.19 24K, I'm okay with that. It's all looking good, let's back it up and move on. We'll start with the frame. Grab the mid plate, that's the one with the chamfered holes. Put on the stack screws that you secure with metal nuts. You can use the square ones we have. Don't forget to put on some blue Loctite. While it's not absolutely necessary, it really sucks if the stack screws come loose. And then we tighten it real hard. Next, the press nuts go on the arms. I put the washers on all screws because I know if I don't do them all at once, I'll forget. Next, I put the arms on. I screw them in, but I don't tighten them yet. Don't forget the keystone. There you go. A drop of thread locker. I twist the screw back and forth so it soaks in. Press nut in the top plate. Screw in but don't tighten. Lock tight. Twist, twist. And when it's all in place, tighten it real hard. Next is the standoffs, but we only put on the front ones for now. And a handy tip to tighten those hex standoffs. You can use a hex head to hold them. And you'll want to make sure to put the flat face at the front. That's quite important. Okay, listen up. This is one of the most important parts of this build. We're gonna plan out the stack spacing. The reason it's important is because most of the time when people crash and smoke their electronics, it's because there wasn't enough care put into making sure the two boards cannot collide with each other or with carbon. Here we can see the CSC is nice because it doesn't have many components on the bottom side, meaning we're going to be able to run it super low, especially because the frame doesn't have press nuts under the stack. For this reason, I'm going to put the gummies upside down, so with the short side on the bottom. Then I'll put it on and make sure nothing can touch carbon even if I press quite hard. The goal being to run it as low as possible to maximize the spacing between the two boards. And you guessed it, for the flight controller, the gummies go with the tall part at the bottom. And as you can see, there's absolutely no way in hell the boards are going to touch in a crash. You know what? I don't want them to compress that much when I put on the stack screws, so let's shorten them a bit. Moving on to my favorite part, soldering. As you can see, I'm using a fairly beefy iron tip, because those large pads can really soak up some heat. And here I'm aiming for a large, shiny solder blob. I'll do the motor pads next. There we go. Before we can install the motors, we're gonna have to put on some slippers. And here's where we use the optional socket head screws, but the provided ones are fine too. And all done. Those prints are very important. They're called wire shields, and they're here to protect your motor wires from being chopped up by your props in crashes. I stick them to the arms with VHB tape, but I still use cloth tape to wrap them up afterwards. It will prevent them from being pried open, and it will act as a second safety measure. Oh, and be careful, there's a right and a wrong way to install them. We're gonna be running props out, so we want the opening to be facing where the prop will not strike. After that, I line up all the cables and slip them in. The next step is to cut the wires to length. I just align them with the pad and snip them in place. And do make sure you hold on to the offcuts, because we're gonna need them. Strip the wires using your favorite method. I like using that kind of wire strippers. After which we bring back the iron so we can give them a thorough tinning and make sure all the strands are soaked. On goes a quick bead of flux so we get some shiny solder joints. And we solder them up. So I'm skipping through some of the soldering because this really isn't a soldering tutorial. However, let me know in the description if you'd be interested in a soldering video. And also remember, this isn't a competition. We only care about the joints being clean and well connected, and it really doesn't need to be perfect. A quick cleanup with some IPA, and here's the result. And let's not forget about that tape I promised. Because of the TPU we'll be using, we're gonna have to redo that pigtail so that the wires come out at a straight angle. So I'll remove the cover and desolder the wires. And I'll solder them back on, coming straight out the side, making sure I don't mix up the polarity. Ground is ground. And as you can see, it fits perfect. And here's why we didn't put the rear standoffs on the frame. They need to go in straight into the TPU, so the whole thing can go on the frame together. Like so, secured with a few screws. So on this board, for some reason, they decided to put the pads very far apart, so make sure you cut them to the right length. After which, it's the same old. Strip, tin, and solder it on. We can now plug in the wire harness. pushing it in all the way, and then grab some glue and apply a generous bead to make sure it's locked in. Next are the cap and the TVS diode, so make sure you line up the negative side. Then I like to add small bits of heat shrink. A quick drop of solder. Then I grab a couple of motor wire offcuts and solder them onto the pads. After which it all gets wrapped in heat shrink. Right, I can now slip it in its TPU. Oh, and before I forget, I'll spot where the negative side is and mark the cable white to make sure I don't get it mixed up later. And actually later is now, so let's put the print on, size up the wires, trim them, and solder them on, making sure we get the polarity right. We'll also want to make sure we fully melt the pad underneath so we get a very good joint. Alright, time to prepare the VTX now. The first step is going to be to remove the coax so we can fit the longer one we bought. And for that we're going to have to snip off the small beads of glue that keep it secured. After that we can use some tweezers to gently lift it up from the sides. And same goes with the camera. Then we can put on the new coax by making sure we align it very carefully. After which I like to use tweezers to push in on both sides until it clicks in. And rinse and repeat with the camera. Alright, now that the coax is installed, we can slip the camera in its TPU adapter, which will let us install it in the front end. It's now time for me to put the O4 inside the AxisFlying Case. Don't worry if you chose to skip it. I designed a couple of adapter TPUs for you that will let you install it the same way in the backpack TPU. Step 1 is to remove the antenna and slip it into our antenna mount TPU, and make sure you push it in all the way. Oh, and by the way, left or right, it doesn't matter. Now snap the antenna back on, and then it's just a matter of following the instructions for the assembly of the case. Now just before we install it, we're gonna need to take care of this cable. In order to avoid any possible conflict between S-bus and ELRS, I always remove the yellow cable. I know it's not always necessary on all boards, but since I don't want to go and check the manual every time, I just make it a habit to remove it. That way, it never becomes a problem. And it's also a good excuse to show you how you deepin a cable. And yes, I know you could just cut the cable and be done with it, but it's a good skill to have, and as you can see, it's not that complicated. We can now install the VTX, routing the cable underneath. We can also install the antenna mount, spinning it around to create a strain relief loop. And the coax cable will be routed between the two boards. Next, we're going to be cutting the receiver and buzzer wires to the exact right length so they don't flop around inside. Those wires will also be routed between the two boards, which we can do because we ensure there will be plenty of room in there to do so. And that way we keep everything neat and tidy. Back to soldering. When I solder a receiver, I always use the white wire for RX. That way, I always know that the white wires needs to go to TX on the flight controller. And don't forget the heat shrink. So for the Wi-Fi buzzer, black goes to ground, red goes to 5V or BZ+, and yellow goes to BZ-, or in this case just BZ. And for the receiver, it's easy. Red goes to 5V, black goes to ground, green goes to RX, and white to TX. Now we can plug in the ribbon cable, apply a bead of glue, plug in the O4 cable, More glue. And we are all good to close it up. For the front bumper, we'll first install the square nuts, after which the camera slips right in and can be secured with the self-tapping screws that come with the 04. Yeah, that's not going anywhere. Next step is to put on the camera plates. We're gonna be using the bottom cutouts of the cam plates to secure the Express ELRS antenna just behind the camera. And just in case you're wondering, I've never had any reception issue when putting the antenna in this location, and it is by far the most durable place you could put it. And the buzzer perfectly fits between the cam plates. Right, I believe we're ready to close this puppy up. Quick durability tip. If you have washers, you want to use them here. Just a few more details to sort out before we can move on to testing. Quick test with the smoke stopper. 2 amp mode so it doesn't trigger. Here goes nothing. Just the motor direction next, and then we can start putting on some props. Let's quickly go through the motor order wizard. It's not strictly required since we mounted the ESC the right way around, but since I love not having to think, I just run through it quickly. Next is the motor direction wizard. I give them a light touch to check the direction. Here 1 and 2 are going the wrong way, so I click 1 and 2, and you can see them reverse. But I still check them all at the end to make sure. Well, I think we're good. I'll put on some props and then I'll meet you downstairs for a quick hover test, because the build is not considered complete until it's lifted itself off the ground. So in general, I would not recommend you do this in your living room. Do it in your garden where it's safe, but here it's raining outside, so I'll just be super careful. Right, let's go. Switching to angle because I suck at line of sight. And we are done. Alright, we're on the spot. Got the quad. I did a small tune for this quad. It's going to be in the description, so if you want to try it out. Now let me show you how it flies. Let's go. You got me hypnotized, I'm under. You got me hypnotized, I'm under. Transfixed, like a rabbit in the headlights, spiraling out of my control. You're taking my mind. Alright, pretty good, huh? That was a really fun session. I had an absolute blast. It flies really well. It's both durable and light, though I'm not surprised it flies well. I know that formula. I've flown it for a while, and yeah, it's still good. So if you're going to try it, please do come to my Discord. There's a link in the description. I always love seeing all your builds, all the small attention to detail you put in yours, and it's just a blast. It's what makes the community so fun. All right, I'll leave you to your builds. See you later. Have a good one.